Okay, guys. Lesson 3.3 is solving systems of inequalities. Now, solving systems of inequalities, you'll notice we are graphing. A couple of things. First of all, if you look at front and back, I think there's a total of 6 graphs. We do not need to do all 6 graphs to know what we're doing here. Okay, so I probably will do, 3 to 4. Okay, something along those lines. Just to make sure we know what we're doing here. We are not using elimination today. We are graphing. Okay, you can't use elimination when you're solving systems of inequalities anyways. So, just typo. On number 1, g plus m greater than or equal to 6. 5g plus 2m less than or equal to 20. First of all, thoughts on the fact that it says g and m? Are you guys okay with the fact that it says g and m?
Maybe g is supposed to be 1.
Okay. So here's what I'm going to say. If you're not okay with that, could you adjust and use x and y instead?
Yes.
Okay. And in fact, I'm going to suggest that we do that, especially since we're graphing here. General rule of thumb is alphabetical. So that means that g is x and m is y. Okay, so that's general rule of thumb. So the first equation we're going to graph is x plus y greater than or equal to 6. Thoughts on x plus y greater than or equal to 6?
Yep.
Okay, and why are we subtracting the x over?
Y equals mx.
Okay, good. We want, because we're going to graph this, y equals mx plus b form. So subtract the x over. 6 minus x, or, okay, if you put the minus x first, it's negative x plus 6. Can we graph this? Okay. How do we graph this? Okay. Y equals mx plus b, so 6 is my y-intercept, so up 6. 1, 2, 3, 4, 5, 6. Then how are you guys getting the next points? Okay. Okay. He specifically said down 1, right 1. And you can go down 1, right 1 as many times as you want. The other option to reverse that is to go up 1, left 1. Up 1, left 1. Dots are important to make your line accurate. However, you're going to notice today, I'm not going to go all the way across. It's not important in the same sense it was yesterday. Now what?
Graph solid line qualities.
Solid line. Why is he telling me solid line?
Because it's greater than.
Because it's greater than or equal to. When it says equal to, do you guys remember? Equal to tells me it's a solid line. I do ask that when you graph lines, make them the length of the graph. Don't make this real short line with graph left over. Okay, make it the length. So this is a solid line, and that's because it was the equal to. What's the other question you have to ask yourself? Where do we shade? My choices are above or below. What kind of line was this? What kind of symbol was this? Greater than or equal to. So recall that we're going to shade above. And above in this case now. Keep in mind, is this all we're doing on this problem? No, we still have a second graph to put on here, yes? So don't make your shading like crazy dark where you can't see anything through it. Okay? It's kind of a light initial shading because we're going to have more shading to follow, and we'll talk about where our solution is once we get there. So next one. On this next one, I'm going to call it 5x plus 2y less than or equal to 20. So what do we do? Okay, to get 2y by itself, we're going to minus the 5x. So if we minus the 5x over here, I now have 2y less than or equal to, what is 20 minus 5x? Okay, so negative 5x plus 20. Now we need to divide by 2. Y less than or equal to negative 5x over 2, or negative 5 halves x, plus 20 divided by 2 is 10. You ready? Where do I start with this graph? Up 10. What about negative 5 halves? Okay, if we go down 5, that's our negative direction, and then right 2. Okay, doesn't hurt to make at least one more dot just to keep our line accurate. Down 5, right 2. What kind of line are you drawing? A solid line, because again it is equal to. Where are we going to shade on this line? Because this one is a less than, this is a shade below. Where is below my blue line? Okay, because of the angle of it, it ends up being on the left. Now, that means I have lots of area to shade here, right? I'm kind of doing a light shade again. Now, my question to you, where is or are your solutions?
Right here. This part right here.
Okay, so general rule of thumb, it's where they both shade, yes?
Yes.
So where they both shade, in this case, it ends up in that little triangle up top. This is why I said don't go crazy earlier with your other shading, because what I need you to be able to indicate is where is your answer. If you turn in something like what I have right here, I'm going to say I don't like that. I don't know where your answer is. I don't feel like you know where your answer is. How can I indicate you know where your answer is? Can you shade this darker? Okay, so wherever your overlapping shading is, that is the key point. Now, you turn something in like that, I feel like, okay, they know where their shade is. They have acknowledged that, okay, it's right there where it overlaps. Don't force me to try and assume, well, did they really know it's where it was overlapping, or did they just shade and didn't really know where their solution was? Okay. Now, technically, when you do this on Math Excel, I don't remember for sure, but I'm not sure you get to do the initial shading. I think on Math Excel, you might just do the final one section shading. Okay. So like when I do it, I usually have two sections that are lightly shaded. One section is not shaded, and then this my solution section. I'm not sure you'll have the light shading in Math Excel. Okay. I think you might just be able to do the dark shade. Okay, questions on this? Does this sound familiar? Okay. Let's go ahead and do 2. And then I'll probably skip to the back after that, so. So x plus y greater than 4. What are you guys doing? Okay. We're trying to get y by itself. Subtract x. Y is greater than 4 minus x, which I'm going to put minus x plus 4. If we go ahead and graph this, what do we know? Up 4. So our y-intercept is always up or down. What's that slope? He says down 1 over 1. Over 1 which way? Let me be specific. Right. Okay, so it's down 1, right 1. Or the option is up 1, left 1. What are you doing next? Dotted line? Dashed line? Because? It's not equal to. Good. Because it is just less than or greater than. This is a dashed or dotted line. And what else am I asking myself? Above or below? That's greater than, so above. And above on this one ends up on the rightish. I'm trying to do a real light shading there. Okay? And honestly, if you're someone you'd rather wait and shade at the end, you could. You just can't let yourself get confused. I would rather shade as I go. Y greater than or equal to negative 1/2 x plus 1. It's already done. Nice, isn't it? We like that when that happens. It's already y equals, so it's already y equals mx plus b. My b value is 1. So y-intercept of 1. Where does this slope take me? Okay. Down 1, right 2 is an option. The other option is rise positive 1, rise positive 1, run negative 2, so left 2. Did you ask yourself how you're connecting these? Solid, because this time it is equal to. And notice, guys, my lines are extending all the way to the edges of the graph, right? That's going to make a big difference in how I, my shading here. It can. Where am I shading this line? It's greater than again, so above. So above this line, looks something like that. Do you know where your solution is? Okay, the section that overlaps, right? So as we look at the section that overlaps, somehow show me, I think my pen just ran out as I was trying to do that. Somehow show me you know it overlaps. Notice I have one section I didn't shade at all. I have a light section, or a single shaded section, a single shaded section, and then I have my double shaded section. Okay. The third example would be very similar to what we've been doing. And we'll flip to the back and get at least, honestly, if it wasn't for the back examples, I'd feel like you guys have a good idea of what you're doing. So just spin all y equals mx plus b. Really? What are we changing up on the back? Have you guys looked? Absolute value. When you see absolute value, what is your brain supposed to think?
Scary.
V. Okay? You have to know that when you see those absolute value, okay, I'm going to be drawing a V. Automatically. You've got to lock that in your head. So, one at a time though. Let's start with y less than or equal to 3. Thoughts? Okay. He says go up 3 and then make the line go this way as he makes a horizontal motion. Okay. This is the line y equals 3 that we're graphing, which means it's going to cross the y-axis at 3. Okay. And so it crosses the y-axis at 3. So there'd be points at 0, 3, 1, 3, 2, 3. If you want dots. That is a horizontal line through y equals 3 if you need some information there. What type of horizontal line am I drawing? Okay. It's equal to. So again, it's a solid line. Above or below? It's less than, so we're going to shade below. Again, don't let your shading overtake everything, right? And I know it's hard for me to shade light in pen. It's easier to shade light in pencil, so. Okay, guys, this is where it is incredibly helpful if you remember something about chapter 2. Okay, specifically something from that end about the absolute value of V's. So we already talked about, because we see absolute value here, this is going to be a V. Okay, where is our just basic absolute value V? At the origin, right? At 0, 0. And remember then, it's at 0, 0, and each side of that V goes up 1 over 1, right? That's your typical V. What changes are happening with this V? Okay, this minus 1, first of all, it's in the absolute value, so it's left or right, opposite the sign, and so this is a right 1. So you want to shift, move, translate something right 1. So instead of my vertex being at 0, 0, it's now at 1, 0. What's the slope on either side here? Yeah, it's just a typical slope of 1. If my slope was anything other than 1, it'd be out front of the absolute value. So up 1 over 1, up 1 over 1. Reverse the other side. And I have a V that looks like such. How am I going to connect the dots for my V? It's equal to, so it's solid. Notice I'm taking my V. Oh, golly gee. Oof. Okay. Sorry, my V got a little bit away from me. Taking my V all the way. I'm extending it all the way through. What kind of shading are we doing? This was greater than, so we're shading above. I have a V. What's above mean? Inside the V, yes? As opposed to below the V, which would be outside the V. So my inside the V looks something like that. And what do you know? Right here? That little triangular part. It wouldn't necessarily have to be in the triangular part. That's just the way it worked out. Where are we at time-wise? There's debating between that V was kind of basic, kind of easy. How about if we look at the bottom one? I was debating between being done for the day or looking at that bottom one, but I feel like that bottom one has, the bottom one? Yeah. I feel like that bottom one has some good stuff in it, so. Okay, y less than negative 3 times absolute value of x plus 3 plus 1. So, as you look at this first equation, what's the first thing you have to be able to tell yourself? It's a v, yes? Okay, you have to identify that this is going to be, or this is absolute value. So when I graph this, it's going to be some kind of v. Now, what are the pieces that you see there? What are these different numbers telling my V to do? Okay. Yeah. So this one's going to be a stretch and a reflect. Now, what can we use that negative 3 as that might make this problem a little easier? Think of it as a slope. Okay. Yes, it's a stretch of 3. It's going to make it a taller, skinnier V. It's a reflection, so it's going to make it upside down. My suggestion, though, just think of this as your slope value. We're going to have a slope of negative 3. What's plus 3 in the absolute value tell me to do? Go left. Because it's opposite the sign when you go left or right. What's the plus 1 at the end tell me to do? It's up or down 1, and it's with the sign, so up 1. Okay? So, we know that we want to shift left 3, up 1, and then we know we're going to have a slope of negative 3. And negative 3 is going to cause my V to be upside down. Okay, you ready to graph that? My V normally starts at 0, 0. So that vertex of 0, 0 is going to go left 3, up 1. There's my new vertex. A slope of negative 3. Slope of negative 3 is going to, from this point, go down 3, right 1. Down 3, right 1. That is your right branch. To get the left branch, you kind of reverse it. It's down 3, left 1. Or you just kind of reflect it over. So there's what your V looks like. Upside down and kind of skinny. Am I going to use a solid or dashed V? This is going to be a dashed V because it's not equal to. And this is a less than symbol. My words and my actions did not match there, did they? Okay, thank you. I hadn't noticed it either, but then those boys over there were giving me this look like, what is she doing? So, I said it, I just didn't do it. Okay. I'm sure you guys have never done that same thing.
It looks like a dash line now.
Okay, is that better? Okay, thankful for white out here. There's my dashed V. What I was starting to ask, where am I going to shade?
Above it. It's gonna be inside.
Okay, less than?
Yeah.
Less than is going to shade below. And so where is below this V? It happens to be inside because my V is upside down. Okay, last part. X plus Y plus 5 greater than or equal to 0. Is this one going to be a V? No, because no absolute value. So, what form should I go for? Y equals mx plus b. So, subtract x, subtract 5. Y greater than or equal to negative x minus 5. Y-intercept of negative 5. Slope of negative 1. So down 1, right 1. Or up 1, left 1. What kind of line am I connecting these with? This one is equal to, so it is a solid line, so I'm safe on this one. And where am I shading on this one? Greater than says above. So above this line is above, right? Where are all solutions that make these two inequalities true? Okay, it happens again to be this little triangle, but right there is where we overlap. It's not that it always have to be there, but that's just the way ours worked out. Okay. Lesson 3.3 in Math Excel is what you guys have going. Okay? We have about 8 minutes. You guys want to peek at your test?
Yeah.